Hello, everybody. This is Mr. Kusaj, and we're up to chapter 3-2, logarithmic functions. Don't forget to put the date up here. Log, short for logarithmic. Log function is the inverse of exponential function, so it's the going backwards. So let me remind you of the exponential function. So an exponential function, right, you have a base and a power equals, say, x, right? For example, 2 to the third power equals 8, right? So what we're asking in exponential is, what is 2 to the power of 3? What is 2 to the power of 3? Why, it's 8, okay? Logarithmic is the other way around. Right? So this is the way we write it. Log, base, some number here, some base, so it's a little bit lower, and then x. So log and x, those go in the same line. B is like a subscript, a little further down, equals y. So if we're to use numbers, it could look something like this. Right? Now notice it's the same numbers, but different places. So here, what we're asking is, 2 must be raised to what power to get 8? Right? That's different from here. 2 to the third power is what answer? Right? 2, the answer is 8, but 2 to what power do we get 8? So for the log, the answer is 3. Right? 2 must be raised to what power to get 8? So if you cover the 8 here and you cover the 3 here, you can see that we're asking the reverse question. 2 to the third power, 8. 2 to what power is 8? 3. That's what you're doing with log. Okay? Don't think about it too much. Once you start using it with numbers, you can come up with your own patterns on how to remember it and how to do it. So let's just go on so we can see some real examples. So how do you evaluate this? Well, what is it really asking? It's asking 3 to what power is 81? That's what it's asking. Right? Y is some power that you raise 3 to get 81. Right? So I can rewrite it like this. 3 to what power is 81? And then you do the math, use a calculator, wherever it takes, and you figure out that it's 4. 3 to the 4th, so y equals 4. Okay? Look at this. 5, right, log, base 5, of square root of 5 equals what number? So what am I asking here? 5 to what power will the answer come out to square root of 5? Well, you would think that's not possible. Yeah, if you remember, square root is really half power. Okay? If you remember, I can write square root of x, or I can write that, right? Half. And square root, power half, and square root mean the same thing. So 5 to what power will give me square root, right? Half. So y must be half. Sorry. So you had to remember, for this one you had to remember from a previous class that square root and exponent half mean the same thing. Okay? It'll take a little getting used to, but it really is simple. Now, let's talk about a little, some basic properties, some facts that always happen, right? So you know this. B, some number to some power always gives you 1. What is that power? Any number, right, to this power is 1. So it's got to be 0. Do you remember that? Any number to the 0 power is 1. That's this. If you have the same number here and here, base, Well, you know that. Suppose this was like 17. 17 to what power gives you 17? The 17 to the first power. So when you have matching there, the answer is always 1. If this happened to have a power here, then it's just x, right? B to the base b and the number to the x, right? So you can just cancel this. Well, you cancel this and it becomes 1. You cancel this and it becomes 1, but 1 times x is x. So these are kind of similar, if you think about it, right? Here's another one. If you have, these are logs. This is exponential, right? I have a number, and here's my exponent, a funny-looking exponent. But if these numbers match, then you can just drop the whole thing and just copy this x here. All right? They look a little weird, but once you start... Sorry, did we not see this? I kind of rushed through this. Maybe it wasn't on the screen. So basically what I was saying here is if these numbers match, just like here, they cancel and you're left with the power, right? Same thing here. You have a power of 1, right? It's invisible. So this all cancels and you're left with 1. This all cancels, you're left with 1, and 1 times x is x. Okay? All right. So let's see how we can use these properties to help us. Well, 5 to some power is 125. Right? Well, if you look at 125 as 5 to the third, then we can use this rule up here where this cancels, and the answer is just this, because these numbers match here. Okay, how about this one? Oh, look, these numbers match here too, like this rule. So I can cancel all of this and just be left with this, right? So think of it like canceling. This cancels, you're left with this. This cancels, you're left with this. Okay? Common log. Common log is understood that the base is always 10. So instead of writing the 10 there, we just understand that it's 10. So if we write, if it's base 10, we can leave it out. So if you don't see a base there, that means we know that it's base 10. Okay, it's a common log. Base 10 is very easy to do because if you take 10 and raise it to any power, you know right away the answer, right? 10 squared, 100, 10 to the third, 10 to the fourth, 10. You're just putting more zeros. So it's a common base, a common log. So the properties, right? This is 10 here, right? So 10 to what power gives 1, right? The 0, anything to the power, I'm sorry. Anything to the power of 0 gives 1, right? What about here? Well, you're supposed to know that there's a 10 here because it's common log, and these match, so this cancels, so you're just left with x, right? Let's do a couple. So you can use the calculator. The calculator has the log, common log button. So all you got to do for the common log, it doesn't have other bases, but it has base 10. The log button, your calculator, is understood to be base 10. Okay? So all you got to do is hit the calculator. Log 10 to what power gives you 0.001? Well, 10, you got to move the decimal over 3 places, so it's -3. But you don't even have to think about that. Use the calculator. The log button, on the calculator is right there. So log, it's asking you log of what? 0.001, and just hit enter, right? so that part is easy. Natural logs. We talked about E in 3.1. We talked about E. Well, it's the inverse of E. So if this is e to the y equals x, then ln is the inverse of e. So these go back and forth. These are equal. You can ask it this way or this way. So properties, just like before, ln of 1 equals 0. ln of e equals 1, right? ln of e cancel each other, and you're left with 1. Whenever you see ln and e together, nothing in between, they cancel each other and equals 1. So for example here, ln e, they cancel each other and you're left with x. eln, same thing, they're next to each other, right? So if e to the power of ln x, they cancel each other and you're left with x. Okay, these are the properties. So we're going to use these properties to help us solve. Now, technically speaking, you could enter all of this in the calculator, but it would help so much to know that ln and e cancel each other. So why do you want to go through all that trouble when the answer is staring right at you? Okay, same thing here, right? They cancel each other. Okay, if you get some funny number without e, so there's nothing cancels here, then you really need to use a calculator. Hit ln 4, right? So the ln button is right there. So ln 4 and then equals. What did I round it to? Right? You just round it to as many places as you need to. Okay, so here you use the calculator. ln of -5, it's undefined. If you try to enter that in the calculator, it won't give you an answer. It's undefined. Negative number, undefined. Okay, so I got some try problems here for you. Oops, those are the answers. So do the best you can. Use the properties. A little more. So let me give you the top first. Use the properties that I gave you. So this could be changed into 9 squared. So the 9 will cancel. So the answer is 2, right? Here, these match, so that cancels. So if you look back at the properties, a lot of these can be done with the properties. You cannot use a calculator with these, right? Because these have bases of 3 and 9, and they're not 10. The log button in the calculator only deals with, here, it only deals with when your base is 10, right? Common log. These are common logs, so it's understood that there's a 10 here. So we leave it out, which means you can use the calculator, right? So all of these, right? Notice cancels here, right? You can use a calculator for all of them, but if you look at the properties, some of them will save you time and you don't have to use a property. Okay? That's it. Do the best you can with these try problems, and then I'll give you the answers when I see you next time. Bye.